Hello, my name is Chris Fernandez. Today I'm going to be showing you how we check for QBV testing on using Ixia and a Wireshark. So first I'm just going to show here on the screen here the setup. So this gives you an idea of what I'm trying to do here. So I have a Novus card that is connected to my DUT. My DUT is this NXP switch. So on the little drawing here in the middle, you can think as this first port here that I call L is my Grandmaster port. So I'm going to be using the Ixia as my Grandmaster port that is connected to port number 1 on the switch. And then I have another port on the switch that is going to an endpoint that I'm calling that's going to be another Ixia port. So the connection is very simple. It's just a connection between it's a RJ45 1 gig internet link between my master port, my switch here in the middle, and my AS. So what I'm going to do, I'm going to establish an AS 2020. I'm going to use GPTP AS 2020 to connect between my master port and my endpoint going through the bridge. And then I'm going to implement QBV on this port here, which is port number 2 of the bridge, with my egress port and my egress port on my Ixia switch. So when I'm sending traffic, which is going to be scheduled traffic right from the master side, which is my speaker, and going to my receiver here on the other side. I'm using a 1 millisecond or 1000 microseconds cycle duration, and each gate it's going to be open for 250 microseconds. I'm using the following gate to VLAN priority mapping. So VLAN priority is 0 to 3. I'm going to be expecting that on gate 1. I'm expecting on gate 2 a VLAN priority 4. On gate 3, VLAN priority 5, and on gate 4, the last gate, it's going to be VLAN priority 6 and 7. And in microseconds, this is how the gates are going to be looking at. When we look back into the Wireshark, we can expect those values here to be associated to each gate. In terms of traffic, I'm using a 100 byte packet. That is, if you add in the preamble and the interframe gap, it's going to be equal to 960 bits going through. And if I'm using a 100% line rate, that means that each cycle, right? Each cycle is going to be able to send about 1,000 packets per cycle, meaning that each cycle can have about 1,000 packets. So let's say 1,000 packets to make it the math a little bit easier, meaning that 250 packets for each gate at the same time, right? So since the gates are open individually, like not at the same time, I'm just adjusting a little bit, and I'm going to be using 250 packets per second as my line rate continuously. And what the math comes down to is if I send packets correctly, the packet is going to reach, I'm going to be sending one packet every 4 milliseconds, meaning it's going to be 4 milliseconds apart, right? So that's what the 250 packets per second will give me. That means that every 4 cycles, I'm going to get a packet for that individual gate. Okay, so I'm not stressing the box out. This is not a performance test or anything like that. I just want to make sure that the gates are open the exact time that I'm expecting, right? So for this test, I'm going to be using my NXP as a DUT. So the first thing I'm going to do, I'm going to go into my DUT here, my DUT, and I'm going to start AS 2020, right? So GPTP gptp.sh start. That will start that will start the GTPT on the bridge itself on all the ports. And in order for me to follow it, I can actually look into I can do a var log on the ports. So I'm just going to do I'm tailing in the logs, right? So I'm tailing in the logs on ports 0 and 1. So what I'm expecting is that you can see here domain 0. So even though I'm using AS 2020, I'm just having one domain 0. And what I'm expecting is that port 0 is going to be a slave for my Grandmaster clock. And my port 1 over here is going to be a master for my slave clock, right? So what I'm expecting in terms of MAC addresses, for example, I can look in here and to see what my MAC address is for my switch. So I'm expecting these here to be a master clock for my slave, right? So first things first, I'm just going to bring up GPTP and make sure that everything works out. In terms of setting up the IXIA itself for this test to work, and I have QVB gate statistics showing up here, two things have to happen. One, I'm not using IXIA itself to send packets that have anything in it, meaning the packets that I'm sending are generic packets. There are no signature or extra signature inserted by IXIA or anything like that, so we can use regular Wireshark to verify this implementation. That means that I have to use what I know about the traffic to identify the traffic that I want to assign to each gate, right? So the first configuration that you need to do, as you know, port number 1 here is my Grandmaster, port number 2 is my egress. And inside here of L1 properties and QVB, that's how I check if the gates come in correctly. I have to implement two things here. One, I have to say that what my cycle time is, and this here is calculated automatically. So all you got to do is just add in the gates and duration that you have. So in my case, I have 4 gates, and each gate is 250 microseconds each, right? So that's all I got to do here, and then I just close it. This is part 1 of implementing this. Like this 1000 here got calculated based on the calculations here, right? So if I change this to let's say 200, you see that my my calculation here will change, right? So 250, and everything should go back to normal. And I have gates open, gates 1, 2, 3, 4 open here. This is all the configuration that I need to do for my port. As you see here, the port will reboot and it will come up again. Now the other configuration that I got to do is to associate my my egress only tracking. So if I'm sending the traffic from another source that is not IXIA, I have to identify things in that traffic that make sure that I know what traffic I'm looking at and what field do I look at to understand how is my classification for the gates will work. So in my case here, I know that my traffic is there are two types of traffic in this configuration, right? There is the PTP traffic that you can see here. PTP traffic, as we know, there is no VLAN associated with it. So one thing that we can do is the traffic that we send, which is going to be at one point is going to be scheduled traffic, it's going to have a VLAN in it, right? And the VLAN has a source and destination. So the destination for that particular traffic is going to be this 1401 here, and it's going to have a VLAN on it. So when I'm setting the traffic that I'm sending, I can just open up here to do a preview of the packet, right? It's going to be something that looks like in hex format. It's going to look something like this, right? It's going to be the source, that's the source destination MAC, and at the end of it, you're going to see this here, this 0181, indicating that is a VLAN here, right? This is how I identify the traffic that I'm actually interested in putting into gates. And then I have to also to say which field, and I'm interested in when I'm receiving that traffic. So not only the traffic is coming from that MAC address, particular MAC address, or and which field I am classifying it into, put it into gates. For that, I create this egress only tracking here. And this here is where I identified the 00. So those are the two left bytes from the MAC address, and the 8100 saying this is a VLAN traffic. So the PTP traffic will not get classified in here. It will not going to get classified as egress tracking. And then I'm looking into and the 4 bytes is that I'm looking for this particular field, and the signature mask being all zeros, meaning I want exactly this value to be counted as my signature, as the thing in the packet that I'm looking at to classify it as my traffic of interest. And after that, I have to say which field am I going to be looking in to actually classify my traffic. So in my case here, I'm looking into VLAN priority, and in there's only 3 bits, right? So this is how you set the 3 bits used for classification here. You do 1, and then everything F is that, like, I don't really care about this, the rest of it that's coming in, right? And that's it. And then I have to send in the QBV. So on my QBV setting here, I have 4 gates enabled. Each one of them have the VLAN priorities that I'm looking at. So gate 2 is 4, gate 3 is 5, gate 4 is 7, and the remaining will go here into gate 1. So I don't really care. So the traffic that I'm sending for verification is I'm using VLAN's priorities 0, 4, 5, and 7. Those are the VLAN priorities that are associated with the gate. And each one of them, if I make them correctly, right, I don't even need QVB if I'm making them being sent correctly as is. So I don't have QVB actually in my DUT right now. So first things first, let's bring up PTP. And for that, you're just going to go into the scenario here, and I'm going to start all protocols. So starting all protocols, what I'm expecting is that those port number 0 is going to be a slave to my master, right? And my port number 2 here is going to be slave to this master here. And it also gives me a configuration for the path delay here. So the average 326. You can go back into the select views here and look at PTP drill down, and get information about what is configured. Right, so if I look into my 2 ports, I have one as a master, and it's actually a grandmaster state, and the other one is a slave, as I was expecting. I'm looking at the offset, right, from between the 2 clocks from my slave, which is very, very close. So this is 0 nanoseconds. And I can look at the path delay calculated here, which about 322 or so, which matches whatever, matches pretty closely with the DUT is calculating at this time. And the other thing that we can check is this port master identity here. So we saw that the MAC address for that switch is this MAC address here, which is the master for my slave port, but the grandmaster is actually 1101, which is this Ethernet here. So I know that everything is now correctly going through the switch, and the switch is giving you the master clock being passed on. So everybody's looking at the same clock at this time. So right now everything is looking good. So the first thing I'm going to do, the first test I'm going to do here is sending traffic that is actually scheduled. So what does that mean? That means that I'm sending traffic correctly based on my gates already without QBV being involved at all. Right, so I don't have QBV yet on my DUT here. So if I send this traffic here, this traffic is sending correctly. So the flow number 2 here, which is going to hit gate number 2, has a start delay of 200 microseconds already. So it's going to be doing the right thing now already. So if I send this traffic here, I'm only sending a few packets. So it's only 100 packets for gate 1, 200, 300, and so on. So if I send this as is, there's no need for QVB testing, because there's no QVB configuration, because I am already sending it correctly to hit the gates correctly, right? So what this is going to tell me is that I'm going to be sending 4 flows here, that it's going to be hitting the window, and it's going to validate the window correctly as the traffic has been sent correctly already. So I don't have to do QBV, right? So, but now let's break it, right? So how do I break it? Let's say now my gate number 2 here is no longer being sent in the correct timing. So I'm going to send this to 0. That means that at gate, the first gate, two flows are going to come in, right? From a flow that has VLAN priority 0 and a flow that has VLAN priority 4. Both of them are going to come in at the same time at the port at the gate number 1, right? And at that time, gate number 2 is closed. So this flow here should not be able to come in anymore, right? So that's going to be that's going to break my setup for my QBV. So this here should indicate to me that this frame is going to have frame violations here, and it's going to have frame closed, right? So that's what I'm expecting. So let me do it again. So I'm doing the traffic. I'm sending the same thing again, but at this time, this traffic on flow 2 is going to come in at the wrong timing, right? So what that's going to happen is now I have gate statistics here, flow statistics again. I'm looking at that. Let's see if everything comes in first, right? I am expecting everything to come in. What the DUT is going to do is he's going to slow the packet down for the gate 2, but he will eventually send it when he has a chance, when that gate opens, right? So he exactly sent everything. But now if I look at the gate here, I can see now that my gate 2 had violations, right? It came in at the wrong time. So how do I fix this? So one way to fix this would be to actually install or set up QVB on my DUT. So let me just do that. So I'm going to go in here and set QVB. Set 1 millisecond. Set QVB 1 millisecond with 4. So this here is going to set QVB on my SPW1, which is my egress port. So that's all I have to do now. So now that this is fixed, I'm actually going to go and do this test again. But this time I'm actually going to capture. So you can look at what I'm looking in. How do I verify this, right? So I'm going to start capturing here, and I'm going to send this traffic again. This time I'm expecting that all the packets are going to be coming in correctly. And what's going to fix it, it's actually going to be my configuration on the DUT. The DUT is going to have the packet, is going to buffer it and send it correctly. It's only going to enable that packet to go through when the gate opens, right? So I want to see if that implementation is correct. So at this time here, I'm already capturing. So now I'm going to send the traffic again, and I'm going to look at the statistics again. At this time, I'm expecting everything to come here on valid gates, right? Because the DUT now fixed the gating for me, right? So that happened. So that happened correctly. So now let me look at the capture here. I'm going to stop this capture. So I capture a bunch of packets, a lot of them being the control plane traffic that has nothing to do with my traffic that I'm looking at. And I'm going to run through a code here to make sure that I got everything correctly, right? So I'm using some Python script here to just verify what this script does. Let me just save it correctly on my, I'm gonna save this. I need to save this on a particular, so I'm gonna save here. So I need to delete this, and I'm gonna save this as an input. And to make sure that my script is working, what I do usually, I look at the number of packets that are captured, so 2043. And when I run this script, this script should give me a nice valid configuration here. So so I can verify what I can validate what the ICSIA is giving me, right? So everything here came in correctly. And the way I'm looking at it is, if I take a look at this configuration here, what I'm seeing is my traffic. So let me look at the traffic. So let's say for port number for VLAN priority, let's do VLAN priority 4, right? Which is the one that we are sending incorrectly, but the test is correcting itself. So I'm going to apply a filter here. So let me go here, VLAN priority 5, select. I see VLAN priority 5 here. Let's see. And what I'm looking at, or what this script is verifying, is that it goes in here into this epoch time, and the way Ixia sends the traffic is going to be on the top of the second. So the zeros here indicate, so this number here is 867, and then we get into the microseconds, right? Because this is all nanoseconds, so there's 9 values here. So what we're interested in is the value inside here. So 502, 502, this is 502, that's when the packet came in. So it came in correctly on that gate, right? So this is gate number 3. So for gate number 3 is correct, the 500. Now let's look at another one. Let's look at number 4. So at number 4, I can see the 250 here. That's correct, right? It came in from 250 to 500. Gate 7, I'm expecting 750, right? So came in 752. That is correct as well. And VLAN 0, it comes in on the top of the second, so it's going to be 000, right? So 002. So everything is working correctly. That's how I verify. That's how this script kind of verifies that these packets are going into the correct order in my testing. So this is how you test if your QBV is working, using Ixia to verify, using a Python script that I can make available, and also Wireshark the same time. With those 3 tools, you can actually verify that the script is doing the correct thing, that those stats are giving you the correct thing, and everything is coming in on time, right? So the QVB implementation is working correctly. To now be able to identify latency numbers and so on, for that we need to actually create traffic that we generate and we add signature it. So for that is I have another video showing you how to do that. But anyway, this is all I want to show. I hope this was helpful. And if you have any questions, please feel free to reach out. Thanks. Bye.